Okay, so let's take a look at your homework, which was on this sheet. And I asked you to do the first 5 under the velocity and acceleration questions. And I stopped at 5 because we didn't get to acceleration yesterday. So question number 1, remember we did steps in problem solving. So step 1, read the question. Determine the time required for an object to travel a distance of 100 kilometers at a speed of 75 kilometers per hour. So write down the givens. A distance of 100 kilometers. So delta D is equal to 100 kilometers. At a speed of 75 kilometers per hour. So V av is equal to 75 kilometers per hour. And the question wants to know, determine the time. What's delta T? So this is from your grade 10 equation that we went over yesterday and just a few minutes ago in the other video. V av equals delta D over delta T. Remember we had said you're going to rearrange first for the unknown. So you're looking for delta T. What do you do to get it off the bottom? You multiply both sides by it. So it'll be V av delta T equals delta D, and now divide both sides by V av. And no, if you can do this without showing me, that's fine. I just want to show you to make sure everybody can do it. So I'm okay if you go from this step right over, like skip this one and go right to here, if you can do it without screwing it up. So delta D over V av. What's my delta D? 100 kilometers. You write it in with the units. And what's my V av? 75 kilometers per hour. So 100 kilometers over 75 kilometers per hour, 25 goes into both of those, so that's like 4 over 3. So delta T is equal to 1.3 repeating hours. Okay, number 1. Number 2, how fast would you need to go in meters per second if you wanted to go 15 kilometers in 15 minutes? So 15 kilometers, that's your delta D. In 15 minutes, that's your delta T. And it wants to know how fast. You're looking for your V av. But it wants to know how fast in meters per second, which means you need to change both of these. So we change our kilometers by, we wanted to get it to meters, so multiply by 1,000 over 1 kilometer. And we're going to change our minutes. There's 60 seconds in a minute. So you're going to multiply by 60 seconds over 1 minute. And so 15,000 meters, and that is over 900 seconds. Okay? And so now we find our V av. So V av is equal to delta D over delta T. You don't even have to rearrange this time. So 15,000 meters, 900 seconds. 2 of the zeros divide, so it's like 150 divided by 9. But 3 goes into both of those. So 50 over 3. So what is that? 116.6 repeating, I think. But I'm doing it in my head, so if you get something different, that is why. Just a sec, I'll check it on my calculator, since you're not here to tell me if I'm right. Oh, look at that, it is 16.6 repeating. All right, number 3 says, how far would you travel if you went 120 kilometers per hour for 3,600 seconds? So how far would you travel if you went 120 kilometers per hour? So that's your speed. There's no distances here, or no directions here, so you don't have to put in east or anything yet. So how far would you travel for 3,600 seconds? Okay, that's my time. Notice speed is in kilometers per hour, time is in seconds, so you got to convert one of them. It doesn't say how far would you travel in meters, so I'd be tempted to convert this one because that's just 1 hour. And then you do, oh, and you're looking for how far, delta D. So you do V average is equal to delta D over delta T. To get the delta D alone, multiply both sides by V av. So we have delta D is, multiply both sides by delta T. So we have delta D is equal to V av delta T. And so it becomes V av is equal to 120 kilometers per hour by 1 hour. Higher order math that I think I can do without my calculator, 120 kilometers. Number 4. Number 4 says an Olympic athlete runs a 100-meter sprint in 9.83 seconds. What is his speed? So he runs 100 meters, and he runs it in, so that's your delta D, and he runs it in 9.83 seconds. And it wants to know how fast, what's his speed. Okay, don't have to rearrange. V av is equal to delta D over delta T. 100 meters over 9.83 seconds. That one I am not doing in my head, although it will be just slightly over 10. 9.83, and you get 10.173. 10.173 meters per second. If I were to look at sig figs here, I'm allowed to have 4, so I'd have to cut that 3 out, and it would be just 10.17 meters per second. Okay, number 5. A train leaves a station at 36 meters per second. So the 36 meters per second is our V av. How long will it take it to travel 1,620 meters? That's my delta D, 1,620 meters. How long? I'm looking for delta T. So again, V av is equal to delta D over delta T. Rearrange for delta T, so multiply both sides by it, so that you'll have V av delta T equals delta D, and then divide both sides by V av. So delta T will equal delta D over V average. Delta D was 1,620 meters, and the speed 36 meters per second. And so we end up with a time of, it might be 45. It is 45 seconds. Okay? So now you look at your questions. Because if I was grading this, if you were handing it in, it would be 1 point for your givens, 1 point for the original equation before it was rearranged, 1 point for the equation after it was rearranged, 1 or 2 points for the numbers you filled in with their units. So the 1 or 2 points depends on how complicated the question is, right? So this would be 1 point, but if there were no units there, you would lose that point. And then 1 point for the right answer with the units. So if you didn't show any of your work, if you didn't write down your givens, but you got the answer right, well, congratulations, you would have gotten 1 out of 1 out of 5 points. Okay, so I want to see the steps. You don't have to show me the rearranging if you can do it, but the rest of it I want to see. Okay? So the next video is going to show you how to add and subtract vectors, and then I'll give you your homework, okay? But the homework is going to be back on this sheet, but only after we add and subtract vectors.